Welcome. Today we'll have a look at day 5 of Advent of Code 2024, print Q. For this problem, we're presented some data that has two formats. The first format is called page ordering rules, which is this part here, and this pages to produce in each update, which is this bottom part here. So for the page ordering rules, it means something like, for example, 47 must come before 53, and then 97 must come before 13. It doesn't matter, there could be things in between them, but as long as 97 comes before 13, that rule must be satisfied. And if you look though, there's some sort of a chain. For example, 97 must come before 13, but it must also come before 53. And then if we want, we can look, maybe find one, maybe 53 must come before 13. So there's some topological ordering going on there. So for this problem, I had several ideas, but the best idea that I came up with is to use a topological sorting approach. Once you know the topological ordering for each of these values, you will look at each of these. For this, in this case, there's 6 different, what do they call them? Updates. They call these updates. So they want to know if this update is in the right order. So for example, 75 before 47. Well, let's look. In this case, it would be, let's look over this here. And yes, 75 comes before 47. So this is okay. 47 and 61. Yes, that's okay. 61 and 53. Yes, that's okay. And 53 and 29. And that looks like it's also okay. So for this first, what they call update, yes, this is already in order. So as it says here, the first update is in the right order. And for this first problem, part 1, they just want to know, they want us to count the, what does it say? Determine which updates are already in the correct order. So they want to count those. And then once you get that, they want the middle value, and we want to sum them up. And that's the return value. That's the answer for part 1. All right, so I hope that was clear. Again, they want to look through each of these updates and figure out which of these is in the correct ordering, has the correct ordering. Of those, pick the middle value, sum them up, and return that, and provide that as an input. And for mine, that was 4814. So let's start it. So I'll use a default dict for storing our from collections import default dict. So I'll be looping through. Well, let's look at the data first. So data, where is that data test here? So as I mentioned, it has 2 formats. This first part is the ordering, and the second part is the updates. So let's first add this to we'll call these rules. So where's this at? We'll go here. So with open test 5.text. And notice how this is separated by a new line. So we'll keep aware of that. So we'll call these rules, and we'll just have that as a set, and we'll call this updates. Sorry, as a list. Okay. So if line equals a new line, we'll run a separate loop. So for, we'll call this L in F, and it'll look like this here. So we'll do we'll call this updates dot append. So right now I'm working on the part where if I see this here, so I'm looping through each line. If I see a new line, that means the next one is this. So I need to work on this here. So yeah, I need to parse this here. So updates.append, now that line, so l.write strip, the new line character, and then what do we need to do? Oh, convert it to an int. So we'll turn this into a list. Actually, let me see. We'll call this. So that's a string currently, and we'll split it on the comma. Dot split on the comma. So now that's a list, but then we need to turn each of these strings into a number. So we'll do that. So I don't know if we need to do that because these are. I think I will though, just in case. We probably don't need to because, yeah, we probably don't need to because there's no real numeric value here. They're just considered keys and values. There isn't really any numeric greater than in this part. But this is the way I solved it, so I'll just go with it. For I in that. Okay. So now this was, remember, if I capture a new line, that means below it is the updates. Now, and then we can just break. If there's a new line, and then we're done with that, then we break. Now, if there isn't a new line, that means I'm looking at this here. So how do we parse that part? So we say rules dot append. Now again, that'll be a line dot write strip, the new line character, and what is it? Oh, let's split it on the pipe dot split on the pipe, and then let's convert those two ends. Just why not? I probably don't need to, as I mentioned earlier, for I and that. And now let's print it out. So let's print rules. Let's print updates. And let's see what we get here. So let's go here. So Python problem 5.py. Okay, so 4753 and updates. So this looks fine. Now, what I decided to do was throw this into a graph. So I said G equals default dict and a set. It doesn't matter the order of the elements. So then I do for u v in rules. I say g of u dot add v, and then let's print g just to get a look at it. Okay, so that means 47 can travel to each of these, 97 can travel to each of these, and so on and so forth. So that's what we're allowed to travel to. The very next, that's the ones, these are the ones, so 97 comes before each of these. 75 comes before each of these in the ordering. Okay, great. Now we loop through the updates. So let's do that. So for update in updates. So what I did was I said, okay, the neighbors for the first start will be g.keys. Then I say for let me see, u in update, and I check if u is in neighbors, move forward. So let me write that down first. So move forward means u equals, what is it? So using neighbors. So I say g of u. Is that right? Why is that? What is that? Sorry. If using neighbors, like, oh, update the neighbors. Sorry. Then neighbors equals g of u. That's right. So let's go over, I'll go over an example real quick. So let's look at this. So for the first problem, what is it? It's test 5. So they want it, let's copy this down here. So the idea is, for this first update, is this. So that's this here. And for neighbors, so this first set of keys, that's just all of the nodes. So if we look at this here, we can just print it out real quick. Let's print the keys. So print g.keys, and we'll just return. So now let's print it out. So the keys are all of the nodes. And so, and if it isn't in there, that's fine. That just means we don't move on to that node. So if this first key is u, sorry, the first, in update, the first value is u, which is 75. And I ask, then I ask, so, all right, u is 75. Then I ask, is 75 in the neighbors? So the neighbors of the current neighbors are, let me write that down. So neighbors, current neighbors are these here, right? Let's write that down. Those are the neighbors. So I ask, is 75 in the neighbors? And yes, it is. So then I move forward. I say, okay, well, let's find the neighbors of 75. So if using the neighbors, now this neighbors becomes, okay, so what are the neighbors of 75? Okay, so neighbors of 75. Well, let's print it out. So I think we can do that here. Let's print out G. Let's just print out G. For kv in G dot items, print PR. Let's just do B. Okay. Okay, so for this first list, we have 75. So update is 75. U at the first iteration is 75. So I ask, is 75 in the neighbors? And neighbors is initially the keys, which is this here. And yes, it is. So then we update neighbors. Now neighbors equals G of 75. 75 has these guys. So these will be the new neighbors. Then I ask, okay, so now U will be 47. So we're here. Let me just put a little. So we're here. So we're at 47. Now is 47 in the neighbors? So is 47 a neighbor? Sorry, where are we at? So U. So 75. U was the first one with 75. Then now we're okay. Now we're back. Now 47. Is 47 a neighbor of 75? And yes, it is. So then we update. We update it again. So now we're at. Well, what are the neighbors of 47? 47, it has these guys. So we'll put that here. Now I'm looping through update. Now update is now at 61. So let's go over here. So we're at 61. Is 61, I ask her here, is 61 a neighbor? Yes, it is. So then I update neighbors. So now this becomes, what are the neighbors of 61? These guys here. Oh, sorry. Let's do it here. 61 equals that. Okay, great. Now I continue looping. So this part 53, this is this part here. 53. Is 53 a neighbor of 61? Yes, it is. So then I move on. I say, okay, what are the neighbors of 51? Sorry, 53. 53 is 13 and 29. Okay, so you go here. So now the neighbors get updated. Let's 13, 20, and 29. So then now we're here at 29. I ask, is 29 in the neighbors? And yes, it is. So neighbors of 29 equals just 13. All right, fine. And then I loop through the last. Now there's no more elements in the update list. So that means we're good. So what I mean by that is this. So else, this is not okay. So we'll do this here. So that means if U is not in neighbors, that means it's not in the right order. So what we can do is, well, we can break the loop. We can break out of this loop because we don't need it. We don't need a check anymore. And we'll say OK equals false. And up here we'll say OK equals true. So once we get out of this loop, we'll ask ourselves if OK, then we'll add, remember they want us to add the middle value. So the total equals 0. And to get the middle value, we'll do something like, so the length of update, and we'll divide it by 2 using this integer division. And that'll be the middle, and we'll say update, and we'll get the middle index, which is that, and we'll add that to the total. And this should be it. Let's print f total. And let's run that. Oh, let's save it. Let's save it. Let's clear this and run. Do I need to print anything? So total is 143, and I think that was what we're looking for here, 143. So that was that. Let's see this. Let me go over this really quickly again. So what I did was I used a default dict to store the neighbors. So every time I loop through all the rules and I add if I'm allowed to travel to V. And so I get the default dict, which is kind of like a graph. And then I loop through all of the updates. So I check if for every element in the update, which is something like this, I say, can I move on to 47? And then, so by doing that, I update the neighbors and the element. So this loops through this list here, and I update the neighbors here. And that means, can I move on to you? Can I move on to you? can I move on to you? I'm always forwarding the neighbors, and it's pretty straightforward after that. This took me a while to come up with. I tried uh, union find, that didn't work, and then I also tried sorted containers with a sorted list, and that didn't work as well. And then this was my approach. Um, so that was it for this part one. What I'll do is stop the video here for now, um, because I think for me the video is a little bit too long, and I'll create a second video for part two. Until then, I hope this was helpful. If not, leave a comment, and I'll try to re-explain anything if anything is still unclear. Other than that, have a great day. Take care. Goodbye.